Hello, physicsers. In physics, we have a very specific way of going about solving problems. What I'm going to do here right now is to show you the proper method, the proper format that we want you to use when solving any physics problem in this class. So, of course, first things first, I need to read the problem. And FYI, this was number 7 from your most recent homework. So I said an arrow leaves a bow with a speed of 42 meters per second. Its velocity is reduced to 34 meters per second by the time it hits its target. How much distance did the arrow travel over if it were in the air for 2.4 seconds? So what we have to do is ask ourselves, what information is given in the problem, and we need to assign those variables. So we said the arrow leaves the bow with a speed of 42 meters per second. Well, it leaves the bow with that speed, so that would be our initial velocity, and remember that is v sub o. So we have v sub o is equal to 42 meters per second. We then have the velocity is reduced to 34 meters per second by the time it hits the target. So we also know a final velocity, which is just v. So we know final velocity is 34 meters per second. And then next, I ask how much distance is traveled, okay, and I tell you it's in the air for 2.4 seconds. So I tell you the time is equal to 2.4 seconds. Now, what we need to do is look at our nice equation sheet. Find your best friend, locate it. So let's take a look and see what allows us to solve for distance. We're looking for distance here. So we're going to put d is equal to a question mark. So let's get our orange physics sheet out. Do any of our equations give us enough information based on what we have in the problem here to find distance? So we look at this, v equals delta x over delta t. That's not going to work for distance for us. We look at x is equal to x sub o plus vt. Also not going to work for us because we're looking at a change in velocity. So that we have two velocities, not just one average velocity here. So that won't work. X equals x sub o plus vot plus 1/2 at squared. Well, we do know we can use that to solve for distance. But if I look at this, I'm missing a critical value. I don't know what my acceleration is. So I'm actually looking at a two-step problem here. That's why I wanted to show this one to you. So we know this is the guy for solving distance, or typically we can use some other equations to do that too. So before we actually find out how far it goes, let's figure out its acceleration. So what we do have is we have initial velocity, we have a final velocity, and we have a time. So I can use v equals at plus v sub o, solve for my acceleration, and then plug that into my little distance formula there. So let's go ahead and do that. So first, what we want to do is write the original equation. Always, always do that. And that equation is v equals at plus v sub o. Now, this is the format we're expecting you to use every time. If you don't expect full credit on a problem. You have v equals at plus v sub o. We need to first find, like we said, acceleration so we can later find the distance. So I'm going to algebraically rearrange this equation to solve for the acceleration. So I want to get acceleration all by itself, so I'm going to subtract v sub o from both sides. So I have v minus v sub o is equal to at. Well, I want acceleration all by itself. So what do I need to do? I need to get rid of that t on the right-hand side. I'll divide both sides by t. So I end up with a is equal to v minus v sub o over t. So I just algebraically rearrange that equation. We're expecting that every single time. So now that I rearrange that equation, I can actually go through and solve for acceleration. So I'm going to say a equals my final velocity, which is 34 meters per second, minus my initial velocity. In this particular case, it is 42 meters per second. And notice how I leave all my units in there. You should always do that. Over my time interval, which is 2.4 seconds. All right, and now we need a calculator. So let's go ahead and do that. Right now I have a dead calculator in my hands, so it's always helpful to have one that works. That's a little bit better. So let's clear all this other garbage. Now we're looking at here, I'm just going to go through and actually solve. So let's find a place where you can actually see it. That glare's kind of bad, but I think it'll work. We would have 34 minus 42, and then divide that by our 2.4 seconds, and we get negative 3.33. So our acceleration is equal to negative 3.33 meters per second squared. Now if we look at this, guess what? Our units, meters per second squared, they actually make sense, because if we look at it mathematically, we're taking meters per second and dividing it by seconds. So we're left with meters per second, or meters per second squared. So there's the first part. Remember, this is a tougher problem. It's a two-step problem, not the norm, but I wanted to show you guys a tougher one as the example, while you guys will do some easy ones later. So I now know my acceleration. I just said I can use my x equals x sub o plus VOT plus 1/2 AT squared equation to find out what distance it traveled. How far did it go? So if you remember before, I said in this equation, if I don't give you an initial position, just make it 0. So goodbye initial position. Let's see if we can use the rest of this, though, to solve for our final distance, or our final position here, how far it went. I know v sub o. I know time. I know acceleration now. I just solved for it. And I also know time again. So I'll rewrite that now. X equals VOT plus 1/2 AT squared. Almost there. Let's plug our numbers in and keep the units. Always, always keep the units. So initial velocity was 42 meters per second times time, 2.4 seconds, plus 1/2 times acceleration, negative 3.33 meters per second squared, times time squared. A lot of people forget to square the time. Do not forget that. We get 2.4 seconds. Got to square that. Now, if we look at this, units are a big thing in physics. If you actually have correct units on your final answer, a lot of times you did the problem correctly. If we look at this, we want to be left in units of meters. Well, meters per second times seconds, those seconds are going to cancel out. We're going to have meters per second squared, and after we square that, that's going to be seconds squared. So guess what? Our seconds go bye-bye as well. So now we're just left with plug and chug. So let's go ahead and do that. We have here now, let's try to get this out of the way. We'd have 42 times 2.4 plus 0.5, 1/2, times negative 3.33 times 2.4. Do not forget to square that 2.4. And we end up getting, it travels a distance of, wow, pretty far, 91.2096 meters. So we get x is equal to 91.2096 meters. Always like putting a box or a circle around our final answer. So there you go. There's a basic, well, slightly complex physics problem, but that is how you appropriately solve. Write down all the variables. Write down your knowns and unknowns. figure out what equation or equations you need to use, and rearrange them algebraically. Then we go through, plug our numbers in with units, and solve. So remember, not everything's a two-step problem. This was a more difficult one, so I wanted to show you a tougher one. Most of the problems you guys will do will just be a one-stepper. So there you go, Physics 101.